All right. Whoops. Am I actually streaming? Yeah, it looks like I'm actually streaming. There we go. All right. More going through Vulkan. But yeah, this right here is something I worked on along with AI, and I'm just going through it to make sure I understand, what is going on. Before it wasn't using dynamic rendering, and I was just loading a mesh and then I put a texture on it. But then I learned that uh, Vulkan has a new thing called dynamic rendering, and then I changed to using dynamic rendering, and yeah. So what I'm doing right now is just kind of going through little, just different parts of it and making sure, like, I mean, I had an idea of what was going on when I was going through this before, but I want to make sure I really understand it. Um, like I'm trying to understand cues more. So is my OBS is picking up my audio, and I like the graphic, the what is it, the family graphics cue. Where is it? I don't know where it's at. I'm gonna actually make this smaller so I can have an easier time seeing it. Excuse me, and then make this bigger. Small text. There we go. That's so much nicer. Although I don't, it's probably hard for other people to see, but sorry. It's easier for me to see now. So, what is it? I'm trying to find it. Get physical device family properties right here. Trying to understand a little bit about more about that. AI tells me that there's different like sections on the GPU, like one dedicated for like graphics, one dedicated for. I'm gonna actually look this up in the documentation as well. See if it says anything. Family. Q family. Here we go. I was just there. Now I moved. I'm gonna look this up. I can't. I think it's a compiled shader from what I understand. Explain. Because I used. See, this is my vertex shader, and this is the compiled shader, and then I had a little. Where is it at? No, not that. And I'm also writing this entirely. I'm using just C to do this. Uh, Obviously, I don't like C++. Um, I think C++. Okay, it can be useful, but the problem is there's too much crap that can make things too confusing, but it can definitely be useful. And I think there's good C++ developers, but people overuse features that they don't need to have, and they just keep adding crap to their code that they don't need. And that's the problem with C++, is that people like to add things they don't need to all the time in their code, and that's when it gets really annoying. And then you have to like figure out like, okay, well, what are they doing here? And then you realize they didn't need to do that thing, and that gives you like a headache after a while. And plus, if you're trying to understand something complicated like Vulkan, I've seen a lot of people who learn Vulkan in C++. It was great, I guess, but not for me, I guess. That's too much on my brain. So the more I can understand without getting with less abstraction, the better for me. So, and it helps me understand Vulkan better. And I'm using the Vulkan header, Volk, VOLK, so I can put the function pointers directly in. And I learned this yesterday about instance level pointers and device level pointers. Uh, there's a difference between them. So like instance level pointers just loads. So it does specific things uh, where does that? This is like querying physical devices, properties, creating surfaces, or picking a GPU. So that'd be like, yeah, instance level pointers, and then device level pointers. Um, VK device, logical connection to a specific connection GPU. So yeah, those are the different function pointers. Um, oh, where? Okay, where's the part? Where's the? Do I compile? I might. Yeah, I guess I compile. Do I compile the shader? Yeah, GLS LC. Yeah, this is where I compile the shader. I honestly, because I had AI write this make script. I don't know what the symbol means in make. Time for a new chat. Can you explain this recipe? I'll do that. What is going on in this make recipe? It's a wildcard. It matches any stem file name. So anything with .vert. Why not use the star? Yeah, why would you just not use a regular? It's common, while both look like wildcards, they function very differently in a makefile. It's for existing files. Oh, it's for creating new ones. Okay, so these are for files that don't exist. Let me check my. I'm still streaming. Yeah, audio is good. All right. More going through Vulkan. Although I don't. It's a wild. Yep. Okay. If you ever need a file that looks like, and you find, here's the recipe, and build it. Okay. What I like to do is put everything that AI says into like a dump. I call it make dot. Did it copy? Where did it copy? That's what I. just so I can look at it later if I want. But yeah, I don't know. I much rather be doing this than actually like learning a ton of crap about Vulkan than actually um I don't know. I much rather do this than a lot of other types of programming. Because then I get to learn a ton of crap, and the more I get to learn, the funner it is for me. The more hand holding something does for me, it's harder. But at the same time, like you, of course, don't want to like write an assembly and crap like that. So there is some level of like, I want this to do have some abstraction, but then, you know, okay. So I get what that is. All right, fine. Oh, oh, I didn't know that. Well, I guess that makes sense. Well, it's just like compiling C, I guess. Oh, wait, no, no, no. It's the middle ground. It's a binary format between high level. Okay. Wonder if I. Well, let me think about. That's all right. Okay, yeah. All right, I get it. All right, we're going through it slowly. Makes the GLFW windows device, get a device, get physical device support. So here we're getting the families. So we're getting uh, information about our graphics card and whether or not it supports graphics or whatever else we need to find out. Then physical device support. Oh, Chronos, okay. That's what KHR is. The thing that sucks is it'll take me to the like file it's in, but not to the exact spot, so I gotta do this. Oh, device surface support KHR. Um, so we get the device. This is the index. This is the surface. Where's the surface? I wish I could. I need to change it. Really don't know how to change it to where you can search without moving your cursor. That does definitely get annoying because I want to search within this area. It must be a global variable. Yep. Surface. So we created the GLFO, created the window surface. Now we're getting device support. All right. Oh, this is just checking. All right. Nice. And PRES. Does it just return just a true or false? Oh, yeah. Okay. That's easy. It just says true or false, but supports presentation. So so we get whether or not it supports presentation and if the graphics family supports graphics and it also supports presentation, then uh, I gotta figure this out. I don't know how to word this because I don't like that. It's really bad. Yeah, I don't like the fact that it does that because I just want to search in this area and it's like, okay. Oh, I didn't know that exists. Let's try that. See what that does. Match. Okay. I don't even remember what I was searching for anymore. Oh yeah, okay. Yeah, that didn't move my cursor. Oh, I did know. Okay. That's just yeah, it's part of. So that's what I need. I need to make a shortcut that does that because I hate searching for something and then I move around the file when I just want to look at all of the um, things in that one part of the file, and that gets really annoying because I don't feel like doing it myself. All right, let's see if this works. Leader S. Do I have something set to leader S? I do not. Sweet. Clear the highlighted match. I already have something to clear the match. It's so that I don't need that last part. They have a leader F. Highlight under cursor without moving. Manually type a pattern to highlight. Okay, nice. That's. Do I have anything for leader F? No. Yeah, I definitely need that. Both of these things. Interesting. Let's see if it works. Restart Vim here. Didn't throw back an error, so that's cool. Now let's open up our main and see if I can use it. If I can find where I was at. I was in main still, I think. So, see, in that sense, it's helpful when you jump like that. But it's not always helpful. Sometimes it's super annoying when you search and it jumps around. Okay, let's try this again. I was looking for graphics Q family. It's probably a global variable, I'm guessing, but leader. Oh, leader S did not. I have that mapped to something else, don't I? Leader S. I do. Oh no, yeah, I do. Okay. Dang, and I use that all the time. What should I remap this to? Let's try leader F. Nice. It's exactly what I wanted it to do. Oh, we do need something to clear the highlight. probably like, why are you having AI do this? Well, I could do this, but I want to spend more of my time learning Vulkan, so I use AI on the things that I have AI do everything for me for the things that I don't care about as much, I might have to frickin' change it and make sure make it work correctly if it doesn't, but let's see if that works. So search for something underneath my pointer, leader F, leader F. Again, toggles it off. Yeah, buddy. It's slow though. It is very slow. I only use function word. That can't be right. Let's see if it works on the word too. It does. Yeah, that is slow. It works though. So I'll live with it, I guess, for now. Then let's rename this F maybe? Like leader find. Yeah, that I guess I could do that. Like find. Search for there we go. Nice. I like it. And I could wait, this whole time could I have done that? What did I map it to again? No, I already forgot. Leader. Oh, I just mapped two things to leader F. Maybe this will be leader capital F. I am not the brightest. Okay, cool. Then leader capital F. There we go. Q props. Graphics family. It's global variable. Oh, it only keeps the search within that buffer? That's lame. Does it really do that? Yeah. Yep. Okay, so then we get the... I'm going to make sure I understand this. So I think we're getting the Q family when we do this. So we're getting a surface that supports presentation and a Q family that supports graphics here. Just going to... I'm going to ask to see if I understand this correctly. Does this get a Q family that supports graphics and a surface that supports presentation. Yes. Okay, sweet. It's looking for unified queue family that can handle both tasks. Well, yeah, okay. Yeah, we know that. Yeah, okay. Yep, yep. Oh, I didn't know. Okay, so maybe it might not be the same queue for graphics and presentation. I didn't. Okay. I'm going to keep it like this because it makes it really simple and it works for my machine. And it's just about learning it and not right now. And it's not about making it robust. But uh, yeah. Where is my. I'll put this in here. Yeah, that's. I'm just going to put this here. And then I'm going to copy this. So that I know that. But honestly, other than Windows and Linux, who else is going to be Mac users aren't going to be playing games and nobody really makes games for I mean that's if you're writing a game, but work for every device. Yeah. Yeah. Multi the family that does the graphics might not be the one that talks to Surface. Okay. Yeah, okay, well, I get it. VK sharing mode exclusive. I used to know what that was. Uh, I forget the difference. Uh, okay. Now, okay, so my question is if the you have different cues for graphics and presentation, can you still use VK sharing exclusive? So even with cues, even when the cues are different, in fact, okay, however, cue family transfer, ownership transfer. Well, yeah, that makes sense. Yeah, this makes sense. From the graphics queue to the presentation queue, makes like a pipeline barrier on both sides. Release. Record a barrier on the graphics queue saying, I'm giving up this image, it's going to the graphics presentation. So, graphic from graphics to present. So, you're in the graphics queue and you're doing your crap, and then you're going to send it to the presentation queue. Record a barrier on president's queue saying, I'm taking this image, it's coming from graphics to present. But then what in the presentation queue, other than presenting, what are you really gonna do? I'm gonna okay. If you have different queues, I'm gonna make uh, copying this. So I know. Why does it paste it like that? I don't get why it does it like that. I can do GQ, but it like spreadsheet. I don't want that. I guess that's the kind of sucky thing about Gemini is you can't copy it as a freaking markdown file like you can with ChatGPT. It turns into this crap. I'll just go to my If you have different queues, you have two paths. Okay, that's handling one queue at a time. Handling multiple queues. Writing it out kind of helps me remember what's I don't know. If you write it out, you could just read it, but for me, if I write it out, it stays in my head way longer than if I just read it. That's why I write things out like this. Yeah, it takes forever. Okay, sharing. Just copy that. Whoa, not what I wanted to copy. Pros. Copy, gosh dang it. Pros and cons. To disable certain assume both queues. Path B. The most aggressive memory optimization possible. Cons. To write the release acquire barrier logic yourself. Code for the swap chain. Okay. I am understanding more. Unified separate exclusive. Unified, which is... So if unified queues, that's when you use one queue at a time, it's the best, but you can't always do that if you have multiple graphics card or depending on the operating system. But Windows and Linux usually have the graphics queue and the presentation queue. They're the same queue. Graphics and presentation are in the same queue, but that might not always be the case. That's the more you know. You don't know till you know. I'm not finishing that. Header 1, 2, 3. Strategy, performance, implementation difficulty. Boop. These are going to need some space. Unified Q. I'm going to QU. It's like I'm gonna kill you, but it's I'm gonna Q you. Like it's very confusing. I'm gonna like how do you pronounce? Is it I've been pronouncing it Q, but wouldn't Q be like QUE? So that would this be QU? Say going to kill you. Yeah, I'm going to Q you. Sorry, I say weird things. Conclusive best very easy. Separate QUs and current. See, this is so much fun. I'm not gonna lie, I actually really enjoy doing this. Honestly, I would do this above making using a game engine any day. Like I'll learn this all day. If I have to sit in front of Unity and learn that, heck no. That just is boring. I don't know. It just is boring to me. This is fun because I get to learn all this cool stuff about what's happening at a lower level. Not that I will ever fully understand, but it's cool to know more of the inner workings. Yeah. Look at that. All right, now spent a long time going through QUs. Now we're going to go through, this is the part that goes, and my code has a single queue because it has presentation in the graphics. I'm going to the bathroom real quick, and I'll be right back. All right. I am back, and I forget which thing in OBS is my screen. There we go. Yeah, I'm using OBS. FFmpeg got annoying because, yeah, it's way easier to use OBS. FFmpeg is cool, and you can do a lot of cool things with it, but when you're trying to type a bunch of text for all of your properties, and if you want to add audio, compression to your voice, that gets really annoying to do that all in one command. Whereas it's much easier to just use this and then you can listen to it. Like you have instant feedback of how it sounds. Whereas it's like, yeah. Not that it's bad. Like FFmpeg is awesome. FFmpeg is built into a lot of things and it's great. And I think it's really good to learn. But it's just, you don't have to use it for everything. I'm using it for this face cam, which works very well. I highly recommend you doing that too if you're using Linux, if you want to use a face cam. Oh, look it, there's two people. Hello. All right. So I was on cues. That's what I was learning. We're just going through this piece by piece. That's all I'm doing. Okay. Now we're going through the extensions. I learned about the cues. So what is going on here? Wow, everything was highlighted. Even if I turn off no highlighting. That, there we go. Dev extension. This isn't really working, is it? There we go. I can't unhighlight the match from earlier. It's all right. For now, we do this. We just load the buffer again. And go back. AI wrote us some crappy thing. Dev extensions. Create device. So this is our graphics cube family that we specified. I'm gonna have to look at, what was PRI? I don't remember. One Q pri, okay. I'm gonna have to look up this struct. See what the frick. Okay. Dev extensions. I'm looking up in the API real quick. Okay. Create device. Oh, this is for, oh, okay, this is for dynamic rendering. Okay, this is how we QCI. Okay. I can tell we're supplying the graphics family cues. We're using the one queue, and we're using dynamic rendering. We're telling it to use dynamic rendering. DCI. So we're telling it, here's our dynamic rendering features. So this is the struct for create info. QCI. This is telling us to make the queue. This is our queue. Enable extension count. And then we're using the extension VKR's swap chain extension name. Let's look up our, let's create. VK. I want to look at, nope. This is what I want. Okay, I want to see this. Is that just saying, whoops. Thank you, API, for, no. But what is it? I'm just saying, oh, it's just saying that it's just for this. I'll just ask. Yeah, okay. You only need one worker, right? Yeah, get that. queue priorities. Okay, I'll have to look into the queue priority thing more because I don't know how that works. Yep, yep. This is what I this is what I had this do before. Well, I mean, I say I, but it was me and AI that wrote it. Yep. This is just enabling the swap chain. Is that what? Is this all this is doing? VK. If you okay, yeah, that's fine. If you have to create a second VK for the okay, that makes sense. All right. Does that mean what are the change queue create info? Where's that at? Oh, just change this to 2 and then have 2 QCIs or 2 queues. Okay, that's easy. But I'm curious about this queue priorities. Can you explain PQ priorities more? Like, I don't get that. Oh, okay. Oh, all right. I see. So the higher the value, the more priority it gets. Okay, that makes sense. Oh, okay. That's cool. All right. All right, I get the priorities thing. Each queue can be have a specific priority so they can get more cycles if there's a jam or whatever is going on. Cool. VK get device Q. Yeah, all right. Right, okay. And I guess this is just 0 because we only have one Q. Makes sense. All right, let's look at the VKQ object. All right, that's just the handle. Sweet. And then we create our swap chain. Right here. We get the capabilities of the surface capabilities. So these are the image counts, which is like how many buffers you can write to in your swap chain. I think that's the way I understand it. So typically they do uh, what is it? A 3? I don't remember what it's called. You write to 3 different image buffers at once and then draw typically. Is for like more performance or something like that. Could be very wrong about that. All right, this just tells you how many images the surface can support. What is max image? Contains the largest valid swap chain extent for the surface on a specific device. So largest width and height. Okay, the width and height. So I think extent, does extent mean height and width? I've never heard people say that. Dimensions. Okay. I don't know why I've never heard that word be used before, but that's how Vulkan uses it. All right. So does this mean multiple images being drawn to the screen at once? I'm assuming if it's a layer. In, I guess I don't have to really describe it this much. What are we in? Is it a... Well, I guess they wouldn't be drawn to the screen at once. I'm gonna ask. It'll say if I'm wrong anyways. Think of an image layer. They stack image bundles into a single object. One layer. One standard 2D image. Oh. Oh. Okay. I don't want to learn about that right now. I just was curious about what that was. Transformations, that just rotating it like 90 degrees, just or whatever. Neutral, 90 degrees, flipped horizontally. Okay. Alpha, okay, I get what that is. Okay, this is your specifications for each image. All right, okay, I see. We are in the swap chain still. Got device capabilities. And let's look at our capabilities. Let's look at this format. Wonder if I can just look up. There we go, formats. Supported buffers and images, formats make. Oh, okay. This is just like RGB. All that other fun stuff. I think it even supports like HDR and crap like that. Yep. All right. Yeah. All right. So eight. Okay, I see. Color space. Yeah. Okay, I actually didn't. I don't know why I didn't know this, but I don't. Without defined color space, the number. So it just determines how bright. Oh, whoops. Here we go. Oh, now I lost. There we go. Learning all kinds of stuff. Does it only determine brightness? I think it just is it kind of like a okay. Spaces is the difference between how computers think. Yeah. Is in bright colors to save data. We oh, okay. Yeah, this is interesting. The HDR. I have no idea how HDR colors work. I just know RGB, and then you just have a value from 0 to 255 for red, green, and blue, and then you have the alpha, which is 0 to 125. I don't know if this works anything similar to that, but that's all I know. An advanced Vulkan application using SDR color spaces like HDR10. Wow, okay, the color space handles metadata. Uh, I know RGB values are 6-digit hex values where, what is it? Each 2-bit represents a color. I'm going to explain this kind of poorly, but whatever, it'll get what I'm saying. A similar way. Well, standard colors SDR are typically those 6-digit hex codes. HDR represents a much more headroom than 8 bits per channel can provide. Why did I say 2 bits? I knew that was... Well, I got what I was trying to say. A 6-digit hex code can be used... Yeah, okay. Oh, so you just move from the 8 bits per color to 10-bit or 16. Okay. Oh, okay, standard. This. Oh, all right. I see. Let's... How HDR is in memory. This is actually kind of useful to know. All right. So whoops. Okay, yeah, this is, I don't need to write the rest of this down. I kind of. All right, now I know how HDR is represented. But we're not looking for that in here. I go off on side tangents. Formats. So what format are we looking at? What format was chosen? Yep, image count, current extent, supported transforms. Yeah. Yep. Get the format counts. Yep, allocate all the formats into here. But why do we choose the? I feel like that's. Uh, oh, I see. That's what I thought. I thought this code didn't select a format. I'm like, what format? How do I know which one is at index 0? But somehow it's able to. I don't know what color format that is, but it works. I have no idea how it knows. It must be using RGB because I'm that's the values I have in there, like regular 8-bit RGB. Because where is it at? Somewhere when where is not the vertex buffer? When I literally draw the when I have the UVs. So right now this is X, Y, Z, and then UV. Here I think it's in here. No, that's the vertex buffer. That's our rotation. I'm gonna have to search through this whole thing. I don't even know what to search for. Like, I can't use the search command because I don't know what to search for necessarily. Well, I would have used and then a digit. Apparently I didn't do that unless I did that in the shader. Here we go. See? What, are these 8 bits? 1, 2, 3. Interesting. White, white, and this is pink. All right, so I don't think this has an alpha. HDR 10 color picker, is that a thing? Yeah, this is HDR. That's is that a thing? Oh, 32-bit. Alpha. Oh, I'm dumb. There's an alpha in here. Okay. It's because the first this is the alpha. I was thinking the alpha would have been over here because I think it can be different. All right, I see. That's dumb that we just picked the first format. Yeah, so we should be picking a format here. Should do something like that. So we make sure we get an 8-bit. So now we're using 8-bit values instead of it just being kind of a guess. Like, I don't really know. Let's fix that later. Looks the same though. What are the like? How would I like? Why is 0 just that the right format? How did that work out? I don't know. All right. All right. It's been a little bit of time. I might be done streaming for now. Go on to other things. All right. Thanks for watching.